Guys, am I audible to at your end? If you have any means like a audio related problem, just ping me on the chat. So last session we have discussed about this encapsulation, decapsulation, and OSI model descriptions. Okay, and today we will start with this comparison between OSI model and the TCP IP model. Okay, so if you take OSI model, it's a absolutely conceptual model, but TCP/IP is the model which we implement in our networks also. So have you seen this TCP/IP stack anywhere in your computer? If I
Yeah,
want,
net-
hmm,
in
yes,
network
Yogesh,
properties,
correct.
in network
So
properties,
correct. In network property, we can see this TCP/IP stack to be implemented. So if I run this command, it's a short command for Windows environment. We can use this ncpa.cpl. Whether it is Windows 10 or Server 2012, it doesn't matter. This command normally works. Okay, and suppose I have this LAN card. Okay, and I want to set the settings on this. So I have a TCP/IP v4 stack and I have a TCP/IP v6 stack. Okay, so these two stacks are inbuilt in our operating system. If I simply uncheck this, our protocol stop working. Whatever stack protocols are there, TCP/IP stack protocols are there, that will stop working. So guys, DNS server we have discussed. There is a DNS client that's running at our end also. Okay, so that support will be discontinued. Then we will not be able to resolve it because that DNS client is not working at our end. IP will not work at our end because we have uh, disable the stack in our operating system. Okay, if I just uncheck this box. Okay, so if you take older operating system like Windows XP or Windows very old operating system like Windows 98, there you will not see this TCP/IP v6 implemented. Only TCP/IP v4 is there. But nowadays almost all operating systems are supporting TCP/IP v4 and v6 as well. Okay, so OSI model is a conceptual one and TCP/IP is the one which is implemented. But if you refer the technology, like suppose there is an issue with the router, we will not use the TCP/IP terminology. Here the layers are clubbed together. See here, application presentation sessions are merged into one layer as the application layer, whereas transport layer is as it is transport layer. Network layer again is renamed as internet layer, and lower two layers, data link and physical layer, is combined into network interface layer. But as I said, we normally don't use this terminology for referring. Like suppose that there is issue with the router, we will never call it as a internet layer issue. We call it as a network layer issue. If it is an issue with the LAN card, we will never say that this is a network interface layer issue. Otherwise, the other teammates or the other network engineer will get confused whether this guy is talking about uh, router or a LAN card. Okay, so normally we use this terminology: network layer, data link layer, physical layer, but actual implementation is done on this TCP/IP. So this is a protocol suite or protocol stack. Okay, where multiple protocols are there. Okay, so on layer 2 we have Ethernet, token ring, frame relay, ATM, means I mean to say network interface layer. So this Ethernet protocol nowadays we are using. Token ring and frame relay, these two are like little obsolete protocol. Token ring is again LAN protocol, but obsolete one. Nowadays we are not using this one. Frame relay, some on a legacy network WAN technology we use this frame relay, but it's again means say uh, it's not the one which normally we use. Instead of this we use MPLS network. Instead of this we use some other technologies, but this technology is not that much used nowadays. uh, Older version of CCNA we were having a practical on frame relay for WAN technology. Nowadays, this is discontinued now. Guys, this sound problem is faced at all of you. All of you are facing this problem, or only Srijesh is facing this problem? Somchat, am I clear at your end, Hussein?
Yeah, I can hear you clearly.
Okay. Alfred, am I clear? I'm audible enough at your end?
Yes, it's good for me.
Okay. Shrijesh, can you check your internet connection, please?
Yeah, actually, I have around a 10 MB, sorry, 100 Mbps connection.
Okay, okay. I don't know
I
because
think
here
some
my
internet.
network is also stable. I'm not if let me check
Actually,
if it is continued.
my connection is a lease line connection. So
There should not be a problem at your end then. If it is continued to have a problem, then just ping me once. I'll shift to another SSID wireless connection.
okay, no,
Probably that
no
will
issue.
sort out this issue. So guys, we are discussing this different protocols on network interface layer. So WAN, this some LAN protocols are there, Ethernet token ring, and frame relay, ATMs. Beside this is not the only protocol on LAN or WAN. There are few more protocols are also there. Because any WAN protocol that we used on network interface layer on data link layer beside the listed one which are there in the diagram.
Which one?
These are the listed one. Frame relay is the WAN protocol. ATM is also one of them. Do you know any other WAN protocol that we use on data link layer or physical layer?
OSPF.
OSPF is the one which works on the upper layer actually. Upper layer, I mean to say like IP layer. This
WAN BGP.
BGP works on application layer. That's a TCP based protocols.
Sorry, what?
Have you
What's
have
the
you
question? I didn't understand very well the question.
Alfred, you're asking, no? So my question is, Alfred, you understood my question?
No, I didn't understand you very well.
I'm asking like any other protocol beside the listed one in the diagram on the network interface layer or on the data link layer?
Yes.
Just discuss that. So we'll be having a discussion on that then. Any other protocol? Alfred, you understood my question, no?
Yes, I understood your question.
So I guess there is one more protocol like triple P, HDLC. I hope I was hoping I was expecting that someone should coin that word. So triple P HDLC is the one we used on lease line or WAN technologies. Okay, so that we will have a practical also on the upcoming sessions like WAN technology. That's a very last session actually. Okay, so these are the protocol we have on the data link layer, on physical layer, or we can say on a TCP IP stack network interface layer. Okay, on network layer or on internet layer we have a protocol, internet protocol, IP. Okay, so all addressing scheme is also based on IP. We'll discuss the IP header afterward in detail. And ARP is the supporting one. Icmp, Igmp are the supporting one for the IP. Okay, so we have one practical on ARP. We'll discuss ARP in detail afterward. This practical will perform. Overall, what is the role of ARP? Anyone knows the role of ARP overall?
The address resolution protocol.
Correct. The full form is Address Resolution Protocol. And for what purpose we are using ARP in our network?
We use we
Mhm.
use AIP to translate to resolve MAC API exactly.
Okay, okay. As Somchat also responded on this, so to resolve MAC address. So if you know the IP address and you don't know the MAC address, we use this ARP protocol to get the MAC address. Okay, so we'll have one small practical afterward. Then we have ICMP, IGMP. So ICMP is used in utilities like ping. It's used for connections checking. So and IGMP is used for multicasting. Okay, so we will try to analyze these protocols afterward in our practicals. Okay, TCP, UDP, these are on the transport layers protocol. Okay, and we have discussed about TCP, that it's a connection oriented protocol. UDP is a connectionless protocol. We have few more slides for TCP and UDP afterward. Okay, then on application layer we have protocols like Telnet, FTP, SMTP. These are connection oriented protocol, whereas DNS, RIP, SNMP, these are the connection less protocol. Okay, so uh, Telnet, what's the role of Telnet in our communication?
Taking a remote session.
Taking a remote session, correct. So why we need a remote session? Because devices are placed in a place like data center or server room, and normally we access these devices from the knock room, okay, or from network engineer access it remotely. So we need a remote access to the device, and that's been provided with Telnet. There is one more variant to this remote access connection. Instead of Telnet, we prefer to use the another one. Guys, you know which
SSH.
correct, SSH. The difference is security. Telnet is unsecured because of plain text nature, whereas SSH is the encrypted one, and that's why we have to use SSH most of the time. But if the device is legacy one and it's not supporting the SSH, then we could use Telnet as well. But it's avoided most of the time. We have file transfer protocol for backup. Uh, in in Cisco practicals, especially the CCNA or CCNP practical, we use another protocol. Guys, you know any other protocol which we use for backup?
TFTP.
Correct. TFTP is the most simplest form, and there we don't have to provide even usernames. FTP is protected by username and password, but it is again clear text. There is a one variation, SFTP, secure FTP, that could be encrypted one, but this FTP is the clear text. Then we have SMTP, simple mail transfer protocol. Okay, so this is used for mail purpose. Okay, so SMTP we used for sending the mail, and for downloading mail we use another protocol, that is POP protocol, POP, post office protocol, and IMAP is also one. Okay, so these are like few of the protocols that we just discussed here, and these are not the limited one. There are lots of other protocol like HTTP is also there. Okay, then uh, few other protocols are also there, but all of them are not listed here. Okay, DNS is a UDP based, means connectionless. So DNS client is connectionless, but DNS server, if one server is talking to another server, that is TCP based. Okay, and we have a routing information protocol, RIP, that is again using UDP protocol on the background. Okay, so it is used for the control plane traffic, means one router when share a routing table with another router, that time we use RIP protocol. SNMP, simple network management protocol. Okay, it is used for managing the devices. So in knock room normally we have screens that gives the details of the devices, and that information is pulled with the help of this protocol, simple network management protocol. So for monitoring, it is very helpful protocol. Okay, software like SolarWinds, uh, MRTG, PRTG works on these protocols, and it gives a very helpful information to check the health of the devices. So this is like a overall TCP/IP we have discussed. Now we'll try to elaborate it. This network address we'll try to understand on this slide. Next point on in our discussion is this IP addressing or IP network addressing, where we have dotted decimal format. Why we are calling it as a dotted decimal format? Because these numbers are decimal number, whereas the separator is acting as a dot. Okay, so we have this 4 octet. Each octet is represented in decimal format. Okay, guys, why we call it as a octet, and how many bits are there in this number? If you take a binary, because this is for our understanding. Actually computer is understanding it in the form of binary only, right? And this 8 bit, because of 8 bit we are calling it as a octet, and four octets are there, so altogether 32 bits are there. Okay, and guys, why this number is from 0 to 255? Why not 0 to 300 or 0 to 200? Why it is stopping at 255? So again, there is a binary associated with this. So we have a numbering system like this. Let me adjust this. 128, 64, 32, 16, 8, 4, 2, and 1. Okay, so if all binary numbers are like this, 1, 1, 1, again 1, so 8 times 1 if you take, and if you calculate the weightage of all these numbers, it turns out to be 255. So maximum all binary number could be 1, and the maximum value it can carry is 255. We cannot go beyond 255. So if you see any number like this 256, so that will be invalid. We just have 0 to 255 only. Okay, so if any number like this 192.168.1.300, so it will be considered as invalid, because we cannot have more than 8 bit in our octet. Maximum possible value is 8 times 1. That's why this number is just within the range of 0 to 255. We cannot cross that range. Okay, I hope this point is clear for all of you. Next, this IP address, minimum three points should be there, or 3 parameters should be there to have the computer on the network. One is IP, the second is subnet mask, third is the gateway. Okay, so if you combine this, means what is the role of mask? So mask dictates which portion of the IP address is the network and which portion is the host. Okay, so in a layman terms, or in a simpler terms, we can understand like wherever you find 255 is your network portion, wherever you find 0 in subnet mask is your host portion. Afterward we will go little beyond this also, like you can find a value like 240 here, you can find a value like 252 here, but keep it simple at this level. We will consider that wherever we have a network portion, we will consider 255, wherever we have 0, that will consider it as a host portion. Okay, and that gives a mask. Okay, mask means hiding something. So if you apply a mask to the IP address, this host portion will get hidden and only network portion will be exposed. Actually, there is a binary ANDing behind this. So if you take any value like this, suppose the IP address goes like this: 10.1.1.10 slash 8. Okay, or I can write it in a decimal format, the subnet mask like this. Okay, so we have to convert tens by number 10.1.1.10. If you convert it into binary, it will be like this: 000 1010, then dot, and 1 means 000, then 001, then again dot, and again 10 means. Then what will be the subnet mask binary? Binary for subnet mask will be like this. Now do a binary ANDing on this. So what output we will get? See, if you multiply 1 with any value, the output is the same. And if you multiply any value with 0, what will be the output? If you convert back into network decimal format, it will be like this. Guys, you understood what from this discussion, what I did in this calculations? This is binary ANDing. So in subnet mask, actually binary ANDing is done in the background. Shrijesh, is it clear?
Yeah.
Alfred, Hussein, Somchad, because you can
Yes.
respond in a chat if you understood this. I think this is a pretty simple concept to understand. Okay. Next we have one more point in this gateway. Okay, so the gateway address and the network IP address should be same. See here, if you apply the network address here 255.255.255.0, so the network will be 172.30.5.0, and the gateway address is 5.1, and the computer address is 5.82, 5.83, but they are in the same network. Okay, uh, what is the role of gateway in our IP network? And normally we termed it as a default gateway. So what does it mean? Why we are calling it as a default gateway? Uh, what the word default stands for? It forwarded the traffic from one networks to another network. So guys, let me take one analogy or one diagram here. Suppose we have one switch and it is connected with a router. Okay, like this one router we have, and we have PCs connected to this network. Okay, and if this PC wants to communicate with each other, do we require a gateway in that case? We don't require in that
Not required.
gateway in that case, right? Because it's like a, consider it as a colony, one colony, and one graph from one house is going to another house, so not required to cross the gate. But suppose this guy wants to reach to the marketplace, Okay, this guy wants to reach to the marketplace or airport or railway station. Then it has to go through the gate of the colony to reach to the main road, and then it has to reach to the individual places. Okay, so if I want to go to the Google or Yahoo, suppose this company is not Yahoo or Google, so we have to go to the gateway, and from there we can go elsewhere. Okay, let me put one more scenario here. So suppose we have one more router, and this router is connecting us to another branch office of our same company. Okay, so one small branch we have, and that branch is connected to this another router. This is our main router, we can consider it as. It's connecting to the internet. It is connecting to the internet, whereas this router is connecting us to the branch office. Okay, so amongst these two router, which one should be called as default router? This router or this router? Which router should be called as? Suppose this is
Branch.
router 1 and this is suppose a router 2. Okay, so which router we call it as a default router? Whether router 1 is a default router or whether router 2 is a default router? Guys, you can answer me in a chat board. Router 1, correct. See, take an analogy applicable here. Like suppose we have one small garden to the colony, and this small gate is opening to that garden. So we cannot consider it as a main gate or a default gate. The default gate is the one which will connect us to the main road, from where we can reach to the places like office or to the market or the airport or the railway station. So this will be considered as our default gateway. Okay, so there could be two router in our environment or multiple router in our environment, but only one of them will be considered as a default gateway. Okay, not always. We could have a scenario like this also. Suppose this is uh, a branch router. This is our branch router. This is our router connected to internet. That time we will consider it as a default router. But suppose it is again connected to one more router or one more office, one more LAN here. Okay, here we have it is connected to LAN, and this network is further connected to a router which is again connected to internet. This could also be a possible situation. So that time our router is the default router, and for this router this is the default router, and then it reached to the internet. This could also be possible. Okay, so most of the time you will see the default router is the one which lead us to the internet. Okay, I hope this point is clear for all of you. Okay, so let's move ahead then. Just right. So internet normally lead us to the means default gateway is normally connected to the internet, or else it is connected to the router which is in a sequence, it is connected to the internet. Okay, somehow the router which connect us to the internet can be considered as a gateway, default gateway. Okay, Let's do one practical for ARP. Guys, how many of you are familiar with this software, Packet Tracer? Cisco Packet Tracer. It's pretty simple, lightweight software. We can have a GNS, UNL setup also. And afterward, I'll show you how to set up these advanced software also. But first of all, we'll start with Cisco Packet Tracer. So all of you are familiar with this software? Okay, okay. Okay, no problem. I'm demonstrating this, and furthermore, I have uploaded this software in my drive also, Google Drive, so you can download and install it. Okay, it's pretty simple installation. Just next, finish job. The software you can use. The same version I'm also using. So let's take one small scenario here. So I'm using this uh, switch, entry level switch 2950. Okay, and I'm using few PCs here, and I'm using one server as well. Okay, let me connect them together. So I had two ports here, fast Ethernet and RS-232. So I'm using Ethernet protocol and Ethernet switches. So fast Ethernet connections. Fast Ethernet means 100 Mbps. I can take any of the ports. Let me take one here. Okay, and I have two cables. One is straight cable and one is cross cable. So guys, I'm using straight cable. Is there any specific reason why we have to use straight cable and not the cross cable?
Yeah,
What's the
straight
reason?
cable for different type of devices.
Straight cable is for different types of devices. So we can consider this PC and switch as a different device, and that's why we are using straight cable. Whereas if you have switch going to be connected to another switch, that time which cable we should use? That time we will use cross
Also,
cable. This cable we will use, right? So let's connect it here. So let this cabling done first. Then we will decide what network we are going to use for this. So I'm taking this note to write what network we are going to use for this. 192.168.1.0, very simple network, okay, with /24 subnet mask. So this is my switch. I'm not going to configure switch as of now. I'm just going to configure this IP address on the individual PCs. So we'll take PC 0 first, and let's give the IP here on IP configuration. Gateway in this network, do we require gateway in this network?
no.
As it is a flat network and it's not going to be connected to any other network or internet, so we can skip the entry of gateway, default gateway for this network, right? So we can skip it. Then for PC1, means second PC, this is PC1, I'm using this address 1.11. Okay, for PC2 I'll use IP address 192.168.1.12. Okay, so I'm following one pattern, like PC0 is 10, 1 is 11, and 2 is 12. Okay, and server I'll take is very separate address for this, 192.168.1.2. Okay, so on a command prompt on Windows machine as well, how we check the ARP table? is the ARP entries is there or not, sir? Like my machine, I have command prompt. So if I want to check ARP table, how I can check it? ARP dash A. So it will ex it will expose whatever ARP entries are there, that will be exposed here. Okay. So likewise on packet tracer also we can run the command ARP dash A. So as of now I don't have any ARP entry, right? So if I try to ping to, I'm on PC 0 and I want to ping to this PC 1, uh, PC 1. So IP address is 11 for that. Okay. So I got a reply here. So if I now check the ARP entry, I have a MAC address of PC1 populated on ARP table. Okay. Now this if I want to see in action how this ARP is working, I can use a mode of the software called as simulation mode, and that will explain me how this protocol is exactly working. Okay. So by default all protocols are analyzed, but I don't want to analyze all of them at the same moment. So I'll just click on the show all and none. So then this will be removed. Then I'll go to edit filter and I'll just click on ARP and ICMP. Okay, so only two protocol I want to analyze, ARP and ICMP. Okay, and then I'll generate a traffic. This time I'll try to ping to PC2. Okay, so PC2 IP address is 12, right? So see guys, try to analyze this protocol now. We have a purple color ICMP packet, and on a simulation it shows that it is in the parking lot, whereas the other green color ARP packet will be shooted first. If I click on capture and forward, then it will be shooted. Okay, and if you open this packet you will see the details. Source MAC address is there. That source MAC address is PC0 MAC address, whereas destination MAC address is all F. So what is this all F?
Don't know.
uh, all F means, guys, anyone know about this, what this all F means?
Actually, that system don't know what is the destination MAC address.
Okay, that's why they put the all F, but there should be some significance of this all F address, means how this should be treated on the switch.
Hello?
Correct. So as Somchat said, this is the broadcast address, and more specifically if you go, it is a layer 2 broadcast. We have two types of broadcast, layer 3 broadcast and layer 2 broadcast. So this is layer 2 broadcast, means MAC address on a broadcast. Okay, this is broadcast MAC address, we can say. Okay, so uh, see, this MAC address is hexadecimal value, and what is the max possible value we have? 0 to 9 and A to F. So F is the max possible value. What are the bits in a one F hex value? If I want to write one F in a binary format, how I can write it? Because you understood my question, no? Means if I want to convert this F, all F into binary, what will be the value for that? Yes, Alfred, you want to say something?
11111.
Correct. How many one? This one,
Eight.
yes. Alfred, is what you said?
I said it will be 81. Then when we convert it, that will be 255.
But it is a hex value, no? 255 we don't have here, we have F value, right? So F means 4 times 1, correct? And how many f we have? We have 12f. So 12 multiplied by 4, it should be 48, correct? As the Somchad has said, the one f value represent 41, right? So if we have 12f, means we have 4, this 12 multiplied by 4. So altogether 48 times 1 we have on the broadcast address. So this, whenever switch is hit by a frame whose destination MAC address is all 1, binary 1, that time, or all 12f, that time this will be broadcast to, or this will be flooded to all of the ports. Okay, this function is called as flooding in case of switches. We'll have a detailed discussion on switching afterward, but simply it will be flooded. If I click on this capture and forward, you see it will be delivered to all of the PC1, PC2, server 0 as well. But these PC1 and server 0 is going to discard it, whereas PC2 is going to accept it because it is destined for them. Because the destination IP address mentioned there is this source IP address is 10, right? And the destination IP address is 12, and that is matching with PC2. So that's why PC2 is accepting it. I hope this point is clear. And this is ARP request. If I write it on a, okay, here it's like ARP request, and the ARP request is in the form of broadcast. Okay, and ARP reply. Now let's check how the ARP reply goes on, whether it is a broadcast or unicast. See, this is unicast. MAC address, source MAC address is PC2 MAC address, and destination MAC address is PC0 MAC address. So it is unicasted traffic. Okay. So see, if guys, if I want to give a general example for this, let me write it first. It is a unicast traffic. Okay. So suppose a live classroom is there. Okay. And I want to talk to first day. This is like a first day of the class, CCNA class, and I want to talk to Hussein, suppose, and I don't know who is Hussein. So what should I do in the class? I'll call out the name, uh, like, who is Hussein? Please stand up, or please raise your hand so I can identify you, and then I'll start a discussion with him. Okay. So likewise, here also PC0 know the logical address, that destination IP address is 192.168.1.12. So we know the source IP address, we know the destination IP address, we know the source MAC address, but we don't know the destination MAC address, right? That's why we have to figure out the destination MAC address with the help of our request and our reply. Once we get a destination MAC address, then our park ICMP packets will be released, and then it will be delivered to the individual computer. I hope this point is clear for all of you. Is it clear for all of you? Now, my next question for all of you is, how significant is this protocol in our troubleshooting scenarios? How we can utilize this for the troubleshootings to test the connectivity with this one computer to another computer, or one device to another device. Suppose there is a firewall in our network and I want to test the connectivity with that. Can I use this ARP for that? See, every device ping is not enabled. So some servers are there, pings are disabled. Some PCs are there, pings are disabled. But if I am able to get the ARP of that device, fulfill, means I'm sending ARP request and I'm getting a ARP reply. So I have a connectivity to that device. We can come to that conclusion, right? So this protocol is very good in terms of troubleshooting, in terms of understanding the connectivity with the device. Okay. Next, we have this discussion of the different classes of addresses. Nowadays, we are not using this classful addressing scheme, but to have our discussion complete and furthermore to understand the classless also, we have to understand the classful. Okay, so we have these three ranges: class A, class B, and class C. Okay, so the class A range is from 1 to 126 on the first octet only. I don't care about the third and second or fourth octet. I just care about the first octet to identify the class of the IP address. Okay, so this range is from 1 to 126, whereas B is 128 to 191 and C is 192 to 223. Guys, you know any, it's like, what is the reason we are keeping it to 1 to 126? Why not 1 to 100 and then B to, in B we have uh, 102 or 101 to 200 and then 201 to 255? Why it is in between the ranges? Any reason for this? Why we are keeping this net the ranges like this? Alfred, Somchart, any, you know, what's the reason we are keeping this numbers in between? Shijesh?
We are talking about the host, the number of
Mm-hmm.
hosts.
Number of host? No, no, I'm not talking about number of host. I'm talking about the ranges. Why this range is like a 1 to 126? Why not 1 to 100?
Uh,
127 is reserved, that's correct. But why the range is ending up on 126? Why not on 101 or 100?
it's from different classes,
Yeah, that's
and
different classes. Uh, yeah,
the
because first bit is fixed to 0. Somchart has given the correct answer and I have listed it here also. See, here also I have listed it. If you look at the second row in our discussion of this classes, the first bit is 0 in class A, whereas for B we have 10 reserved, for C we have 110 reserved. And if you do a calculation on this, you will easily understand this. Let's try to do a calculation. So if we have first bit 0 in case of class A, let's write it here, class A. Let So any value we can have after that. So I'm writing x, x, x. Okay. So minimum we can have value like this. Let it write. And maximum value could be like this. Okay. So this is equal to 0
so
and this is equal to, what is the value here? Okay. We have to find out. 128 is not there. Okay. Because the first range is 0. Next we have 64. Let me do a calculation in a reverse way here. This value of this last weight of this last bit is 1. Okay. Second is 2. So let's 1 plus 2 is 3. Okay. Then this has a weightage of 4. So plus 4. So it will be 7. Okay. So up to this we have 7. Then 7 plus Here we have weightage of 8. Okay, so it will be 15. So this will, up to this we have 15. Okay, after that this has a weightage of 16, so it will go up to 31 now. So up to this we have a value 31. Okay, next if you add 32 in that, okay, so it will go to 63. Okay, so up to this we have 63. Okay, and if I add 64 in that, it will be 127. So this total value here is 127. So exact range is 0 to 127, but we cannot take 0 to 127. Instead of that we take 1 to
120.
126. Why we are skipping 127? I guess Somchat has answered for that. 127 is reserved for the local host, that is used for testing purpose. So we cannot use 127. So we can use 1 to 126. Okay, that's how the range is calculated for class A. Likewise, we can have a calculation for class B as well, and likewise we have a calculation for class C as well. I'm leaving this calculation up to you, but that's how we have to calculate it, or that's how we have to interpret it. I hope this point is clear for all of you. Okay, delete this. Next, this subnet mask, default subnet mask, here we have, okay, 255 for class A 000, then class B 225500, class C 22255, then 0. Okay, number of hosts we have 2 raised to 24 here, and that comes out to be 16 million hosts in a class A. Means a big range we have, big range of hosts we have, where the number of networks are less. 2 raised to 7. Why 2 raised to 7? Why not 2 raised to 8? Because the first bit is reserved, that you cannot use, right? So only 7 bits are there that are subjected to change. So only 2 raised to 7 means 128. Only 128 combinations are possible in class A. Whereas in class B, again 2 bits are reserved, so 2 raised to 14, because we just have 14 bits that are subjected to change. So 2 raised to 14. Okay. So we have 16,000 number of networks, whereas in class C we have 2 raised to 21. Okay, because total we have 24 actually, but total 24 network bits are not available because first 3 bits are reserved. So only 21 bits are available, 24 bits are not available. So 2 raised to 21, if you calculate it, it goes around 2 lakhs. If any doubts on this level, just ask me, or we will move ahead. Next we have the same things explained in a different format. 0 1 0.
Hello.
Yes.
Actually, I have one doubt. In class C,
Mm-hmm.
maximum is 2,97,000 of host.
Yeah.
That is not
Miss
correct, right?
no, this is not host actually. Number of host is 256 only. That is again theoretical.
Okay.
256 theoretical hosts are possible. It means 2 raised to 8, because only 8 bits are there for the host portion. This 0 means host portion, 255 means network portion, right?
Hmm.
So only 8 bits are there for the host portion, so only 256 combinations are there. That is again first and last value you cannot use, so 254 combinations are allowed to be used as a IP address.
Hmm.
Okay, whereas network portion we have 24 bits, but amongst this 24 bits we have to skip first 3 bits, right? Hello.
Hello.
Okay, okay. No, I guess someone is asking someone something. So is it clear, Sujesh?
Yeah.
Okay, okay. Next, we have the concept of public address and a private address on a network fundamental concepts. So public address, as the name suggests, we can use it for the internet, whereas private address is for the internal network. Okay. We can use public address in the internal networks also, but it's it will create some problem in if you use a public address in internal network. That can create some problem that we will discuss in a NAT section. Okay, but internally we have to use these addresses, uh, this private IP address range, 10 range, 172 range, and 192.168 range. So these ranges we have to use. So class A is a pretty straightforward, like all whole range of 10 is considered as a private range, whereas class B and class C is little tricky. So first we'll discuss about class C. So 192.168.0.0/16 range is considered as a class C. Okay, private IP address range. So see guys, if we have address like 192.0.2.10, let me write it here. 192.0.2.10. So will it be a public address or private address? As you can see there, the first 2 octet should be 192.168 only, but here we have 192.0, so obviously it is a public address. Okay, if you take any other address like 192.168.1.100, so we can consider it as a private address. If you take 100.100, that will again be considered as a private address. Okay, and this 172.16.0.0 range is also a little tricky. Okay, so here suppose I give address like this 172.16.10.10, whether it will be public address or a private address. It will be private address. But if I take address like this, one 172.16.10.10 can be considered as a private IP address. But if I take a 172.10.10.10.10, then it will be a public address. Why? Because it is not falling in the range of 16 to 31 for the second octet. Only if it is falling in this range, then we will consider it as a private IP address. Okay, so it is a little tricky. Actually, this subnet mask is /12. Here we have /16. We have to take care of that. This is this subnet mask is little tricky. We'll discuss about /12 subnet mask afterward when we discussed about the subnetting. But only this block is allowed to be like 16 to 31 in a private range. Okay. Loopback address we have discussed. So if I ping to 127.1.1.1.1, so it is a loopback address. What if I ping like this? Guys, can I consider it as a loopback address? Can I consider this number as a loopback address? Which Somchat has said we can consider it as. Guys, what's other students' view? Can we consider it as a loopback address? Okay, Shrijesh consider it as don't consider it as a loopback address. Okay, Alfred, what do you say? Is it a loopback address or not? Hussein, what do you think? Is it a loopback address? Let's test it. Okay, let's test it. So guys, it is responding us back. Now Shrijesh, you consider it as a loopback address? See, the reason I'm saying it is a loopback address because this whole range is a loopback address with /8. Any address you take, any IP you take on 127.0.0.0 network can be considered as a loopback address. That's one of the big mistake they have made while designing IPv4. They put whole range of IP address just for testing, okay, that they resolved in IPv6, but for IPv4 this is the mistake they made it. Okay, so be clear with this any IP address on this range is a loopback address. So this is again a loopback address. This is also a loopback address. Okay. Okay, let's move ahead then. And we have a concept of auto configuration that I'll discuss after a discussion of DHCP. For DHCP, we'll do one practical, and along with practical, we'll try to understand DHCP and this four-way communication happening between the discover, offer, request, and acknowledgement. So let me set up this. So this network we are using 192.168.1.0. Okay. So let me remove this IP address. Okay, from all of the computers. Okay, so I'll remove the IP address. Now we'll set up a DHCP here. Okay, this same network we will take. This time we will make this server as a DHCP server. Okay, so we should have a IP address on the DHCP server. See guys, we cannot have a DHCP based IP address on the DHCP server because or any of the server, not only DHCP server. If you take any of the server, we should have a fixed IP address on the server. Okay, because clients are dependent on the server for some specific services, and if the server has a floating IP address, client will be in a trouble to find out the service. Okay, so the server should always be having a fixed IP address or static IP address. Afterward, I'll go to the on DHCP server, I'll go to this services tab and I'll go to this DHCP section. Okay, and my service is off. First, let me configure it. So let's configure the gateway address. So we'll consider gateway address as 1.1. Most of the time I use this 1.1, but it is not required to have the first IP address on the default gateway only, but it is for the sake of simplicity, I'm keeping it 1.1. Then address 11 onward, I'll give the lease to the client machine, and suppose I have just 5 machines, or suppose I have just 10 machines in my network, so only 10 machines. DNS server, suppose 8.8.8.8 is my DNS server. It's a Google DNS server, public DNS server. It will not be reachable in our communication, but let something we will set it here. And I saved all the settings. Okay, then afterward I switched it on. Okay, I just have one interface here on the server end. So only this interface. Okay, now I'll go to the client machine and I'll raise a request. So I got the IP address. Okay, so this, how this communication is happening, and how this client machine is getting the IP address with the help of these four messages: discover message, offer message, request message, and acknowledgement message. This first message is initiating from the client, and this first message is a broadcast based message. Okay, this first message is a broadcast based message. Why this first message is a broadcast based message? Let me show you this in a action, so, on a simulation mode. So I'm keeping it in a simulation mode, and I'll go to filter, I'll go to this DHCP. Okay, so only one protocol I'm analyzing now, DHCP protocol. So this PC has already got the IP address, so there is no message on DHCP now from PC0. Let's go to PC1 and raise a request. So because of that, this DHCP protocols invoked, and this is a DHCP client running in TCP IP stack of our computer, where on layer 4 we are using UDP protocol. It's a connectionless protocol. Source port number is 68 and destination port number is 67. So what is source port and what is the destination port in this particular case? Source is a client. So DHCP client is working on port number, UDP port number 68, whereas destination this DHCP server is working on UDP port number 67. Okay, this is our source IP address 0.0.0.0, whereas destination IP address is 255.255.255.255. That's, so what is this, what is the special about this address? We have discussed about this address, right? This is layer 2 broadcast. So what we can say about this address, this particular address? Guys, you can
Layer
answer.
3 broadcast.
Correct. That's our layer 3 broadcast address, where all, if you convert it into binary, so this 255 will be converted into 8 times 1, and likewise 8 times 1, 8 times 1, so total 38 bit all 1. Okay, so this is our layer 3 broadcast. Okay, and source address is all zeros. Okay, if you don't have IP address, the source IP address will be all zero and destination IP address will be broadcast. Okay, so why this is going to be broadcast? Let me take this. Why this first message is a broadcast message?
Actually, the
Why?
client don't know where is the
DHCP
DHCP.
server. Because client is not even aware of its own IP address. How come the client will be aware of the destination server IP address, right? So that's why the address is a broadcast address in layer 3 as well as on layer 2. Okay, and this message will be delivered to all of the nodes. If I release this message, it has to be relayed to all of the nodes. PC0 and PC2 obviously going to discard it, and DHCP server is going to accept it, because that that port, destination port 67 UDP port, is open on our compute, on our server. Okay, and then it will be replied back. Okay, the IP is yet not confirmed, that's why it is still broadcasting. And what is there in this second message? So second message contains offer. So what offer we are getting here? The offer is 192.168.1.12. This address is available to us. If we want, we can assign this address to our PC1. Okay, so how it is working? See, Suppose we have a pool of IP address. We have this address 192.168.1.11. Okay, onward, and suppose two PCs since morning are already booted up. Two PCs got address like 11 and 12. So third PC if boots up and asks for the IP address, the 13 will be 192.168.1.13 IP address will be offered to that client machine. So likewise in our scenario, we have been offered with the address 192.168.1.12. Okay, and if this client is okay with that, then it will send a request message to the server that I'm okay with this request, this offer, and then server will send an acknowledgement message that the IP address, that particular IP address like 192.168.1.13 will be binded to the MAC address of this client machine for a specific lease time. Normally it is like a 24 hours for a wired infrastructure and 8 hours for wireless infrastructure. So this long, this IP will not be given or allotted to any of the other computer in the LAN. Okay, so there should not be a duplicate IP address in the network. That will be taken care by the DHCP server. Guys, any doubt? If there is any doubt in this explanation, you can ask me, or else we can move ahead also. So this video I'll close. Second. Okay. So this offer acknowledgement message, and at last we will get a this request fulfill, and we should have IP address here. So we got this IP address. Okay. On command prompt also we can run this. Okay. ipconfig/all. It will show us what DHCP server address is there. Okay, and who is leasing us the IP address, and what IP address details we have got from there. Next in our discussion we have a DNS. So for DNS, let me now we'll elaborate a discussion. We'll do a elaborate discussion on the DNS now. Let's consider this. So guys, we are going to discuss now on DNS lookup process. Consider it as a switch. These are like PCs, this server, router. Okay, and we have few server on the internet. Okay, suppose this is our ISP DNS server. So if this client want to access www.google.com, okay, so first of all, what will be checked for DNS lookup? What will be the first point of contact? Guys, any clue on this? Means like what will be first contacted? Whether directly we are going to ask to DNS server, or is there any process happening before that?
First, it will check its own host account.
Right. Is there any particular term for that?
Host a
It's
record.
called as DNS cache. Y- DNS cache means if suppose I'm a user on this machine and 1 hour before someone else was accessing this machine and he has already accessed google.com. So that entry is already there in the DNS cache. Okay, so I don't have to get the public IP address of the google.com from the DNS server. It's already there in the computer itself. Why to ask it to the DNS server, right? So that's called as DNS cache. Okay, so uh, Somchat, any other entry before that? Also, there is one more point where from where we can get the IP address. Correct, this host file. So normally we don't use this host file, but this could be used by the hackers and we should be careful on that. Means like some script file if written, and suppose bank site is there, www.bank.com or sbi.com. In India we have State Bank. Okay, so someone has made an entry like that, sbi.com is pointed to 100.1.1.1.10, and that server is not the actual SBI server. It's a fake SBI server, okay, a rogue SBI server. And whenever you put the username and password in that, that's it. That's what the hacker is looking for. It will look similar as a sbi.com, but it's not the real SBI site. Okay, so we should be careful. Is there any host file entry made on that? So but keep it aside now. Let's suppose we are not considering host file. Okay, so DNS cache will be checked. After that, this user is trying to access suppose yahoo.com. Okay, so now no one has accessed that yahoo.com on this computer. Since last few days no one has accessed yahoo.com. Then what will happen? Then the query will go to the DNS server. The IP address whatever is mentioned on the IP configuration as a DNS server, there this query will be forwarded. Okay, so on which port it will be forwarded and what protocol will be used in that? We had a discussion in the last few points, means like a introduction also I discussed about that. If you can recall, just point it out in the chat board, what port protocol we used and what port number we used for that DNS query. Correct. 53 is the port number, and what protocol we used for that? Is it TCP or is it UDP? And guys, I'm asking from the DNS client point of view. DNS client is using TCP or DNS server is using TCP? But this query is from DNS client, right? So it should be from UDP, means it should be destined for UDP port number 53. If you are doubtful, we can configure one entry here, so and we can cross check this. No, we are now talking about the different protocol. DHCP, we have a discussion on DHCP. We had a discussion on DHCP. Now we are talking about DNS. So it should be UDP actually. Let me show you the configuration here. So suppose this DHCP server is happen to have two services hosted here. One is DHCP service, one is DNS service. Okay, and we'll configure DNS service as well. Suppose here we have DNS service on, and we'll make one entry ready here, www.abc.com. Okay, and IP address we'll put 192.168.1.3. Okay,
Address and name.
we did one mistake. It should be here, home. Now it is correct. Okay, and it's a record being added here. Okay, and let me put one more server here, and I'll put IP address on this server as 1.3, 192.168.1.3. Okay, and I'll configure web service on this. Let me edit few pages on this. Let's consider this welcome to networkers home. Okay, I'll save this settings, and now if I browse www.abc.com, should I get a response or not? See what's happening. Let's analyze it in a. So we'll take DNS, we'll take UDP as well. Is there anything for UDP? Yeah, let's analyze. We'll do it on another computer. www.abc.com. Source port number 1025, UDP protocol, and destination port number 53. What's the problem here? Why we are not getting a reply? Because the destination IP address is 8.8.8.8. Reason, this IP configuration DNS server is 8.8.8.8. So we made a entry on this DNS server. But what is the IP address of this DNS server? This is a DHCP as well as DNS server. So IP address is 1.2. The same address should be leased. Okay. So we should go to the DH services, we should go to the DHCP, and we should make the change here. It should not be 8.8.8.8. It should be 192.168.1.2. Okay, and I'll save the setting. This time, if I raise a request, see this is the old entry. This is the old entry. Let me remove it from simulation now. Still I have 8.8.8.8 as entry. On command prompt, if I want to remove this settings, how I can remove the settings? Is there any options?
Yeah, IP config release.
Correct. We will release the settings of the previous. So I don't have any setting on this now. Then
Okay.
that should renew the new IP addresses, and this time we got the correct DNS server address. Okay. Now if I look for that website address www.abc.com, it should give me an answer. It's giving time request timeout because cable we are not connected. It's like a wireless server. So let it get connected, let it turn into green, and then we should have a connectivity. Everything is correct at the same. Just wait for a few seconds. It takes 30 seconds to turn into green. There is a reason for this to take a time of 30 seconds. We will discuss about it in the switching section. Now it is green. So I hope this should respond now. So you can see here, welcome to Networkers Home. The same web page which we have configured on this second server. This is our web server. So I hope this point is clear for you that port number is always UDP port number 53 for a DNS client from the DNS client. Okay, to the DNS server. When we have one DNS server talking to another DNS server, that time we use TCP 53 because security is also required in that case. There is a protocol called as DNSSEC that's been used in that. Otherwise, from the client end, we normally use this UDP port number 53. Okay, so this query will go to the DNS server. Suppose this is our DNS server. This router is also acting as a DNS server. This router is also acting as a DNS server. Okay, so this query will go to the DNS server, and suppose this client has already accessed yahoo.com. So IP is already cached on this DNS server, so we can get a reply on this first client that whatever is the IP address for yahoo.com. Okay, what if uh, we are asking for a website, suppose www.networkershomes.com, and suppose no one has access within this LAN about networkershome.com, then what will happen? This query will go to router, but router cannot give you answer because this query has no one has access, and this query has not been raised yet before, and this route server is unaware of this. Then what will happen? Guys, you know the concept of forwarder.
Yeah.
What is the role of forwarder in this scenario then?
If it's not under that network, that will automatically forward to
The
mentioned
forwarder.
DNS number.
Correct. So normally this ISP DNS server we consider it as a forwarder IP address. So if we are not able to resolve it, then we will ask or we will raise that DNS query to the ISP's DNS server, and we configure it as a forwarder for that. Okay, the IP address of this ISP's DNS server will be configured as a forwarder IP address. Okay, and suppose this is one client, but another client has already accessed networker's home website, so the answer for that is there in the ISP's DNS server, so that will be given to our DNS server, and we will get that answer fulfilled to the client as well. Clear with this point, guys? Is it clear for you? Okay, now suppose we want to access a website, suppose www.cisco.com, okay, or juniper.com, something like that. So this query is no one has access, so it will go to first our DNS server. Our DNS server also doesn't know about the answer, so it will be given to the forwarder, this ISP DNS server. And suppose no one has access that cisco.com website, then what will happen? If this ISP DNS server is also unaware of that, then what will happen? Guys, if you know the answer, give me a keyword what will be invoked in that, or else just you can chat me that this is okay. uh, but ISP DNS server is unaware. It doesn't mean that we will not be able to access the website. We will be able to access the website. There should be a one layer above server that should be invoked in that case. If any forwarder is configured, it will be raised to that forwarder. But suppose we don't have configured a forwarder here. In that case, what will happen? Let me explain you one more point in this. So it will be raised. This query will be raised to a server that's called as root server. Okay, and under root server we have TLD servers. Okay, under root server, root means dot. So google.com. So under dot we have .com, under dot we have .in, under dot we have .jp, .pk. So these are top level domain. These are top level domain. .us, .edu. Okay, these are the top level domain. So our partial answer will be given that .com server's IP address will be provided, and then next our query will be raised to .com server. Okay, and query will be raised to .com server, and then next .com server will give, if our website, suppose cisco.com, www.cisco.com website is registered under .com, the next query will go to the cisco.com domain. Okay, and under cisco.com domain we have multiple websites or multiple names configured like this, like www.cisco.com, we have ftp.cisco.com, we have mail.cisco.com. Okay, so all these this DNS server is authority over multiple host name within cisco.com. Okay, so authorized answer will be given to ISP DNS server that www.cisco.com has IP address, suppose 200.1.1.1. So that address will be given to our DNS server, and then our DNS server will forward it to the client, and that's how the client will get the answer. So there are total 13 root server all over the world. That's a dot server or root server, and under root server we have TLD servers, top level domain server, and under top level domain server we have authoritative servers for individual domains like cisco.com or microsoft.com or so on and so on. Is it clear for all of you guys? So this is the process through which every host address will be recovered or resolved, provided that should be a authorized, means like a means this domain should be, it should be registered under proper domain. Okay, so if cisco.com is registered under .com, then that will be available to us. I hope this is clear for all of you. Okay. Ipconfig, few of the commands we have seen, all we have seen, release we have seen, renew we have seen. Display DNS will show us the cache. Okay, DNS cache will be exposed with display DNS, and if you want to push or we have to release the previous cache, So flush DNS can be used. If any stale record is there, normally the TTL for time to leave for a DNS record is 24 hours. Okay, so if you want to pushed out or flushed out any previous DNS entries, so we can use this flush DNS command, ipconfig space flush DNS. Guys, next discussion we will do in the tomorrow's session. Okay, this TCP UDP. We'll take a Wireshark capture also, windowing port numbers and MAC address. The CSMS CD I'll take in a switching portion, okay, and cabling part. So tomorrow we will complete this network fundamental portion, and we'll start with the uh, subnetting portion as well. Okay. Meanwhile, I request you to please download this software and try if you can do the same practicals at your end, that will be nice. Okay. So we'll close the session today here, and rest of the points we'll cover up in the tomorrow's session. Okay, thanks. Good night.